Hi, welcome to the Olympiad geometry. Let's continue our study. Today we're going to talk about the circumcenter properties. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Thank you. So, for the circumcenter, we will discuss about the properties first. Let's just say the first property is saying that the circumcenter of a triangle is a concurrent point of the perpendicular bisectors of three edges. That's the definition of the circumcenter, and it's also the property of the circumcenter, right? So basically it's saying that the three perpendicular bisectors of the three edges are concurrent. So let's just prove it. I think it's been proved before, but okay. It's obvious, right? Because circumcenter means that we find a circle, and the vertices of the triangle are on this circle, right? Of course, that all the points on the circle has an equal distance to the center. So this is true, but we want to prove that the perpendicular bisectors are concurrent for three edges. So just draw the perpendicular bisector for the BC and AB. Then we know that the intersection point, let's set it to be O. Then we know that OA equals to OB because O is on the perpendicular bisector of AB, right? So this is L1. O is on the L1, right? This is L2. And because O is on the L2, so OB equals to OC. That means OC equals to OA. So which means O must be on the perpendicular bisector of AC. And in that way, three perpendicular bisectors are concurrent. Property 2. Property 2. A point is a circumcenter of a triangle if and only if the distance from the point to vertices of a triangle are equal. Yeah, that is obvious, so we're not going to prove it. And property 3. Let O be a point on the plane of triangle ABC. O is a circumcenter of triangle ABC if and only if one of the following statement is true. The first one, the angle BOC equals to 2A, angle AOC equals to 2B, angle AOB equals to 2C. Okay, let's say, well, if O is a circumcenter, then this is obviously true, right? Now we just want to prove that if angle BOC equals to 2A, angle AOC equals to 2B, right? Twice of angle A, twice of angle B. Angle AOB equals to 2 angle C. We want to prove that O is a circumcenter. Let's just say O is not the circumcenter. We know that circumcenter satisfies these equations. So let's say O is here, and we find another point, let's call it O prime, also satisfies these three equations, which means we already have these three, and we have another three, which are BO prime C equals to 2 angle A, angle AO prime C equals to 2 angle B, and angle AO prime B equals to 2 angle C, right? We have these 6 equations are valid. Then we know that because angle BOC equals to twice of angle A equals to angle BO prime C, that means BO prime C are cyclic. Right? These 4 points are cyclic. Similarly, we have CO prime A are cyclic, and BO prime A are cyclic. Right, based on these, we can see that BC. So let's call this as circle 1. This is circle 2. This is circle 3. Right? So see these 4 points. Let's just think about are cyclic, and another 4 points are cyclic. That means in circle 1 and circle 2, we have O prime C are on 2 circles at the same time, which is impossible, right? So that makes a first assumption that O is different to O prime to be invalid, which means O is on O prime, right? And for the second one, that if OB equals to OC and angle BOC equals to twice of angle A, right? I'll just write it here. If OB equals to OC and angle BOC equals to 2A, twice of angle A, right? Let's think about that. We find a point that OB equals to OC, which means this O is on the perpendicular bisector of BC, right? And let's call it O prime. So if O prime equals to O prime B equals to O prime C, and angle B O prime C equals to twice of angle A, we just want to prove that O prime is the same point as O, right? And we find the O prime here. It's already satisfies that O prime B equals to O prime C, right? Because it has to be on the angle bisector, perpendicular bisector of edge BC, right? Perpendicular bisector of edge BC. So we already know that angle BO prime C equals to twice of angle A, which means that, so let's just draw another point here. Let's say this is O, right? It satisfies that OB equals to OC and angle BOC equals to twice of angle A. So we can see that angle BO prime C, if, let's say, if O and O prime are different point, then angle BOC is unequal to angle BO prime C. And that's, so we already saying that angle BO we know that angle BOC equals to twice of angle A, and from the problem set that angle BO prime C equals to twice of angle A as well. That's impossible, right? It's invalid, which means the assumption is this one. The assumption is wrong. So that's saying we have the conclusion O and O prime at the same point. Okay. So for property 4, let the length of 3 edges of a triangle radius of the circumcircle area of the triangle to be A, B, C, R, and S triangle. Then we have this. I think we proved this for many times. It's pretty straightforward here. Let's say it's A, B, C. So we have A here, B here, C here. Then we know the area of triangle ABC equals to half of BC sine A, right? And we know that R times sine A equals to half of A, which means sine A equals to A by 2R, right? So we got the triangle area equals to ABC by 4R, right? So we just prove that. Okay, let's see the next property. Property 5. Circumcenter of a triangle, circumcenter of a right triangle is a midpoint of hypotenuse, and circumcenter of a obtuse triangle is out of the triangle, and circumcenter of an acute triangle is inside of the triangle. So this is a right triangle. We know that the midpoint of AC, we already know that AM equals to BM equals to MC in a right triangle, right? So if you don't know how to prove it, it's straightforward. So we just find the midpoint of AC first, and then we can draw a parallel line from M to BC and intersect AB on, let's say this is P, and draw another parallel line from M to draw another parallel line that passing through M in parallel with AB, and intersect BC on Q, right? So we know that P is a midpoint of AB and Q is a midpoint of BC, right? And we know that AP equals to BP, and angle MPA equals to angle MPB equals to 90 degrees, right? And MP equals to MP, which means a triangle APM and a triangle BPM are congruent, right? They are congruent, which means AM equals to BM equals to MC, right? So that's for the right triangle. For an acute triangle, the circumcenter is inside of the triangle, right? Basically, we can think of that for an acute triangle, we actually push this B further away from AC right? And then this point, the point that has an equal distance to point C, and point B has to follow with this point B, right? Which means it's inside the triangle. Similarly, for another case, okay. Now let's consider property 6. Property 6 is an interesting one. It's saying the sum of the directed distance from the circumcenter of a triangle to its three sides positive if the circumcenter is on the interior side of the edge, negative otherwise, is equal to the sum of circumradius and inradius of the triangle. So it's saying that if we have a triangle, let's assume it's an acute triangle, right? A, B, C, and let's say this is a circumcenter, and we find the distance from circumcenter to three edges, right? Let's call it D1, D2, and D3. Here, it's saying directed distance, and it's positive if the circumcenter is on the interior side of the edge, right? What is the interior side? That means the circumcenter and the triangle are on the same side of the edge, right? So for this case, you can see the circumcenter is here. Let's see, for the edge AB or for the line AB, right? Both triangle ABC and the circumcenter are on the right side of the edge AB, right? So that means D1 is positive. And for the line BC or edge BC, both triangle ABC and circumcenter O are on the top of the BC, which means D3 is positive. And for the line or edge AC, both triangle ABC and circumcenter are on the left of the line AC, so D2 is positive. But for another case, O is here and here A, B, C. Now let's say this is D1 and say this is D2. So we just mark it as D1, D2, D3 first, right? Let's explain. Right, let's explain. For the case of so we draw an obtuse triangle here, and for the line BC, see, for the line BC, circumcenter O and the triangle ABC are on top of the BC, so D1 is positive. For the line AB, circumcenter is on the top left side of the line AB, but the triangle ABC is on the right bottom side of line AB, which means D3 should be a negative number, right? D3 is negative, right? But we want to have the correct understanding of the distance. For this distance, it can be negative, right? Because the distance is not directed. So let's give a negative mark here, right? That makes the distance to be positive. For the line or edge AC, both circumcenter O and the triangle ABC are on the left side of the edge AC, so D2 is positive, that's fine. Okay, now it's saying that we want to find that D1 plus D2 plus D3 equals to R plus R, and here D1 minus D3 plus D2 equals to R plus R. We want to prove these two cases, right? Okay. So let's think about the first one. We want to find D1 plus D2 plus D3. What we can get from D1, D2, D3 in a plus form. Actually, we know that if we set this edge as A, this as C, this as B, right? So we know that D1 times C, so half D1C plus half D3A plus half D2B equals to area of triangle ABC, which equals to half of A plus B plus C times R, right? And we know this is 90 degrees, this is 90 degrees, this is 90 degrees. That means OCB, let's call this PQR, right? This midpoint is PQR. So OR, sorry, I was claiming that's not correct. C is a length of AB. So ORBP, right? ORBP are cyclic. So we can use Ptolemy theorem that D1 times BP, which is half A, right? Half A plus D3. So half AB, that's half C, right? Times D3. Half D3 times C equals to RP, which is half AC, which is half B, right? Half B times BO is R, right? This is point R, right? This R represents for the radius of the circumcenter. So that's the circumradius. Okay, that's from the RBPO. What about OPCQ? We can still use Ptolemy theorem, right? We got half of D3 times A, so D3 times A plus, this is B actually, right? This edge is B, and D2, so half D2 times A equals to half C times R, right? PQ is half AB, right? Because P is midpoint, Q is midpoint. So PQ is half AB, which is half C times R. R is CO, right? That's Ptolemy theorem. And for the AROQ, we use the Ptolemy theorem. We got half D1 times B, right? D1 times B plus half D2 times C equals to half A times R. So we plus these, we add these three equations together. So we got D1 plus D2 times A plus C. D1 plus D2 times A plus D3 plus D2 times C plus D3 plus D1 times B equals to A plus B plus C times R, right? And notice that we have, for this one, we have D1 or D3 times A plus D1 times C plus D2 times B equals to R times A plus B plus C. So if we add them together, then we got D1 plus D2 plus DC times A plus D1 plus D2 plus DC, D1 plus D2 plus D3 times C plus D1 plus D2 plus D3 times B equals to R plus R times A plus B plus C, right? Which means D1 plus D2 plus D3 equals to R plus R. Right, that's for the acute triangle case. And now we look at this one here. Similarly, we know that the triangle, the area, okay, let's just write it here, B, A, C, right? Negative D3 represent for the absolute distance from O to the edge AB, right? So the area of O, B, C, A, the area of O, B, C, A can be calculated as actually the area of ABC can be calculated as OBCA minus OBA, right? So ABC equals to OBCA minus area of OBA. Right, so we have A plus B plus C times R equals to this area, which is BC. So half of A times D1 plus this area, right, which is half of B times D2 and minus this one, which is half of D3 minus D3 times this one, C, right? And similarly for OB, let's call this P, this is Q, and this point, let's call it S, right? For OBPS, because angle QSB equals to angle QPB equals to 90 degrees, so this is O angle OSB equals to angle OPB equals to 90 degrees. So OSPB are cyclic. So we got OS, which is minus D3 times this one times this one, right? So half of A plus this one, which is R, times this one, which is half B, equals to this one times this one, and this one is half C, this one is D1, so half C times D1. Right? Okay, and for another case, for the points Q, O, S, Q, A, O, S, Q, A, right? O, S, Q, A are cyclic. So we have, let me just write it here. We don't have enough space to keep the figure and notes on the same page, right? Just say that, look at O, S, Q, A. So we have OS, which is minus D3, times QA, which is half B, plus OA, which is R, times SQ, which is half A, equals to OQ, which is D2, and AS, which is half C, right? Half C times D2. And for OPCQ, it's a cyclic quadrilateral, so we have D1 times this one, which is half B, plus this one, that's D2, times this one, which is half A, equals to this one, right? That is R times this one. This one is half C, so R times half C. Right, okay. Look at this one. So we have R times A equals 2. This one, R times A equals 2. D3B plus C D2. And for this one, R times C equals 2. D1B plus D2A, right? And this one here, you can see this one here, R times B equals 2. D3A plus D1C, right? So we add them together. We got R times A plus B plus C equals 2. For A, we have D3 plus D2 times A plus let me zoom out this a little bit. Okay, now it's better. So here, R times A plus B plus C equals to D3 plus D2 times D3 plus D2 times A, right? And for B, that's D3 plus D1 times B, right? And plus for C, that's D2, D1 plus D2 times c. And we already know that this one here, which means a plus b plus c equals 2 times r equals 2 a d1 plus, okay, r times a plus b plus c equals 2 d1a plus d2b plus d3c. So which means add them together, we got r plus r equals 2 d1 plus d2 plus d3, right? Remember, d3 is a negative number, which is a directed distance, right? Okay, that's problem 6. So let's look at problem 7. Oh, not problem 7, property 7. Property 7 is saying that a line passing through the circumcenter of triangle ABC meets AB, AC on PQ respectively. Then we have these, right? Let's first draw the circle here. Give me 1 second. So we have A, B, C here. O is circumcenter. So let me just draw a line that passing through the triangle ABC, because this point is P, this point is Q, right? And we want to prove this. Just look at the equation that we are looking for. We want to find the sine 2 angle A, right? Which can be extended as twice of sine angle A cosine angle A, right? Twice of sine angle A times cosine angle A, that's sine 2 angle A. And for this one, if we use r squared times 2 sine angle A cosine angle A, what we can get? R times 2 sine angle A, this is angle A. R times 2 sine angle A, that is BC, right? See, this is R. This is angle A. Let's call this M. So angle BOM, that is angle A. So R times sine angle A, that is BM, right? Twice of R, twice of sine angle A times 1R, that is BC, and R times cosine angle A, that is OM, which means for this one we got it twice of triangle area of triangle BOC, right? So let's just use this one. We can get r squared times sine twice of angle A plus sine twice of angle B plus sine twice of angle C, right? It equals to twice of area of triangle BOC plus twice of triangle area of triangle AOC, and twice of triangle area of triangle AOB, right? Which is twice of triangle area of triangle ABC, right? So on the right side of the equation, we have twice of triangle ABC. So what about the left side? If we have AB to AP times r squared times sine twice of angle B plus AC to AQ times r squared times sine twice of angle C, right? Again, we expand this one, so we have AB to AP times R times twice of sine angle B, cosine angle B, R, plus AC to AQ times R times sine, twice of sine angle C, R times cosine angle C, right? So it equals to AB to AP times R times twice of sine angle B, that is AC, right? Twice of sine angle B, that is AC. And R times cosine angle B, that is the distance from O to AC. Let's call it H, G, right? So R times cosine angle B, that is OH. And AC to AQ here, R times twice of sine angle C, twice of sine angle C, that is AB, times R times cosine angle C, this is angle C, cosine angle C is this one, right? R times, this is angle C, the angle BOG, that is angle BCA, right? And R times cosine angle C, that is OG, so times OG here. Okay, now we have it equals to AB AC times OH to AP plus AB AC times OG to AQ, right? A equals to ABAC times APAQ OH times AQ plus OG times AP, right? So A equals to ABAC to APAQ times OHAQ plus OGAP, and OH times AQ plus OG times AP, that is twice of triangle area of triangle APQ, right? And we know that twice of triangle area of triangle APQ divided by APAQ, that's sine angle A. So we got ABAC times the sine angle A, which equals to twice of triangle area of triangle ABC, right? So we see these two are equal, which means this is true, right? For the second part, it's easy. Just shift the sine twice angle B and sine twice angle C onto the left side of the equation, right? And then we got this one, AB divided by AP minus 1 times the sine twice of angle B, which is BP to AP, right? Similarly, for the sine angle C, we have AC to AQ minus 1, right? Because we extract the sine 2 angle C out. That's minus 1, and AC to AQ minus 1, that is CQ to AQ. Okay. We just talk about the main properties of the circumcenter, and we will discuss about the application and the problems related to the circumcenter in the following videos. I hope you like this one. Thank you. See you in next one.